Last lecture we have proved drop perpendicular from focus onto tangent, any tangent to ellipse. The foot of perpendiculars lie on the auxiliary circle. So further to that property, moreover, the product of two perpendiculars from the two foci on any tangent on to ellipse is always v square. So diagram, you have ellipse, x-axis, y-axis, and then you have tangent, and then you have foot of perpendiculars from foci. They lie on auxiliary circle. Moreover, product of their lanes is equal to this. You start solving. Perpendicular from origin onto the tangent. Okay. Then length of this perpendicular is going to be small p, and this angle is going to be alpha. Okay. So we have, in while solving the last property, we have got the equation of this tangent x cos alpha plus y sin alpha is equal to p. This is our standard form, and we have found out p while calculating the other property, that the p square was a square cos square alpha plus b square sin square alpha. We will use that little later, but now you realize that these three lines are parallel, and therefore you can drop perpendicular from here and it becomes a rectangle, right? And therefore this distance is p, therefore sy is equal to p minus ae cos alpha, and s dash y dash is equal to p plus ae cos alpha, correct? So you need sy into s dash y dash, which is p square minus a square e square cos square alpha, and your p square was a square cos square alpha plus b square sine square alpha minus a square e square cos square alpha. Are you there? If you take out this common, then it will be cos square b square cos square alpha plus b square sine square alpha is equal to b square. Minimal calculations. Minimum calculations, and you end up getting product of them equal to b square. Let t be the point on tangent. To ellipse at point P. TR is perpendicular to SP. SP is focus to point of contact. TM is perpendicular to directrix. Then SR is equal to E times TM. Okay. So let me not draw the, this is my directrix. This is my C ellipse. This is my focus. Then you draw tangent at P, something like this. This is your P. P and S you join. PS. Let T be any point on tangent to ellipse. So if I take point P here, not midpoint, somewhere here P. Then TR is perpendicular to SP. This is S, this is P. TR is perpendicular to SP. And TM is perpendicular to directrix. Okay. Then SR is equal to ETM. Of course, this is our x-axis. This is your foot of perpendicular from P onto directrix. Let us call that as M dash. Okay, this is the setup. For any point T, this is going to be true. Prove that. If you join this point K with S, that is also supposed to be 90 degree. Therefore, Sk upon Sp is equal to Kt upon Kp. But Kt upon Kp is Tm upon Kt upon Kp is Tm upon Pm dash. Tm upon Pm dash, and Sr upon Tm, Sr upon Tm Sk upon Sp is equal to Sk upon Sp. काय लिहिले बरोबर लिहिले का मी?
Sir, SR upon SP.
Sorry, Sk नहीं, Sr upon Sp. Sr upon Sp is equal to Kt upon Kp is equal to Tm upon Pm. But Sp Sr upon Tm, if I cross multiply these two, then I get Sr upon Tm. That is what we want, which is equal to Sp upon Pm dash. But Sp upon Pm dash is equal to E. Hence proved. This is called Adam's lemma. Okay, and because it is lemma, it is going to give us one more good result, which will be theorem. I don't know why this image comes this side of the screen. Okay, so because Adam's lemma is true, if AB is a chord of contact, of the point P, then SP bisects the angle ASB. Okay, so diagram. AB is a chord of contact of any point P. That means P is away from the ellipse. So you have ellipse. Then AB is a chord of contact. You have focus somewhere else. Very bad. माझ्या कंट्रोल मध्ये राहत नाही अजून या लाईन somehow. Suppose your focus is here. This is A, this is B, and therefore if I draw tangent at B and tangent at A, they intersect at P, and I am supposed to have PM, PS upon PM less than 1. So my directrix will go and stand here. This is directrix, this is point P, this is A, this is B, this is S. Now what are we supposed to do? PS is going to bisect ASB. Okay, the angle ASB is bisected by PS. Prove this. Okay, so P is any point on the tangent at A and tangent at B. So you drop perpendicular from P onto the focal radii SA and SB. Let those put up perpendicular be RA and RB. Then by previous property, RA, S, RB and P is a kite. Therefore, true. It's a bisect. SP bisects the angle between A, S and B. This is in general true. For whatever P you choose on the time, whatever point P you choose, angle ASB will be bisected by SP, and AB are supposed to be point of contact from tangents through P. Okay, next. If CP intersects AB, in V and ellipse in Q, sorry, then V bisects AB. And CV into CP is equal to CQ square. Diagram. You can draw a diagram where C is the center of ellipse. Okay. Now suppose coordinates of A are x1, y1, coordinates of B are x2, y2. Then tangent at A is x1 upon A square plus y1 upon B square is equal to 1. Tangent at B is x2 upon A square plus y2 upon B square is equal to 1. And therefore, these two lines intersect at x coordinate of P, x dash, let us call it as x dash. X coordinate is going to be x coordinate of P is going to be y2 upon B square minus y1 upon B square whole divided by x1 x1 upon A square into y2 upon B square minus y1 upon B square into x2 upon A square. So if you simplify this, denominator LCM is A square B square, numerator LCM is B square. Therefore, you end up getting y2 minus y1 times A square divided by x1 y2 minus y1 x2. This is your x coordinate. And y coordinate will be x1 upon A square minus y2 upon B square whole divided by same x1 y2 minus y1 x2 upon A square B square, which simplifies to this is x1 and this should be x2 upon A square. Sorry, wrong. This is x2 upon A square, which makes it x1 minus x2, A square gets cancelled, B square divided by x1 y2 minus y1 x. So this is x dash comma y dash. So we can straight away write down the equation of x dash comma y dash, which is slope is y dash upon x dash. So y dash upon x dash is our slope, and it will be y is equal to mx. M is the slope. So x1 minus x2 times b square upon y2 minus y1 times a square. This is y dash upon x dash, which is slope, into x. This is the equation of CP. Now you will have to check whether midpoint satisfies this or not, and we will check. Midpoint is x1 plus x2 by 2 and y1 plus y2 by 2. So is this true? Check midpoint satisfies or not. Therefore y1 plus y2 upon 2, is that equal to x1 minus x2 upon y2 minus y1 times b square a square into x1 plus x2 upon 2. Is this equality true? So 2 is cancelled. We get y2 square minus y1 square upon b square. Is that equality true? x1 square minus x2 square upon a square. Is this true? So what do you think? Yes, it is true, because y2 square upon b square plus x2 square upon a square is exactly equal to y1 square upon b square plus x1 square upon a square. True. Both points are on ellipse. Both of them equal 1. LHS is equal to RHS, and therefore V happens to be midpoint of AB. This implies V is midpoint of
सर
AB. बोला.
सर ते थीटानी केलं तर मग लवकर होतं एकच आयडेंटिटी वापरायला.
बरं, चांगली गोष्ट. व्हेरी गुड. कॉस थीटा साइन थीटाने करा, जास्ती चांगलं आहे. चालेल. Now the second part which you are struggling is actually easy, because point P, Q, V and Q dash are harmonic points, harmonic group of points. So because that is what precisely we have done, where your AB intersects. V is a harmonic conjugate of P with respect to Q and Q dash. Note V is harmonic conjugate of Q dash of P with respect to Q dash. Okay, what does it mean? It means, where is my diagram? It means Q dash V upon VQ is equal to, it means Q dash V upon VQ is equal to Q dash P upon PQ. Okay, Q dash V is equal to CQ dash plus CV upon VQ is CQ dash minus CV. Correct? Which is equal to CP is CQ dash plus QP. Do we need QP? Q dash? No, काय पाहिजे आता? CV we have replaced, VQ, Q dash V we have replaced, VQ we have replaced. Now Q dash P. Q dash P is CP plus CQ dash divided by PQ. PQ is CP minus CQ dash. Array, look at this identity. This is componendo dividendo. LHS RHS, componendo dividendo. Therefore, what you can directly write is CQ dash upon CV is equal to CQ dash upon CV is equal to CP upon CQ dash. Correct? And therefore, what is that we are supposed to prove? CP into CV is equal to CQ dash square, which is CQ square. Proved. Understood? The harmonic, that is the purpose why we have shown we have done that T is equal to 0, 4 different ways that look at T is equal to 0, and one of them was harmonic conjugate, locus of harmonic conjugate. So V has to be harmonic conjugate of P with respect to Q and Q dash. Locus of midpoints of parallel chord correct. So find the equation of diameter of ellipse x square upon a square plus y square upon b square is equal to 1. Diameter of find the equation of diameter such that slope of parallel chords equals m. Slope of parallel chords is m. Then what is the equation of diameter? Now this can be done in two ways. Number one, I am not solving, I am just explaining. This is ellipse and you are given parallel chords with slope m. Okay, so you take any one of the chords, y is equal to mx plus c, and the midpoint is say x dash comma y dash. Then sum of the x coordinates of these 2 points where that intersects AB. Sum of the, midpoint of AB should be x dash. X coordinate as well as y coordinate. So you will get a relationship, and x dash y dash belongs to this line. So x dash is equal to m, y dash is equal to mx dash plus c. You can express c in terms of these 3 and eliminate c, and hence you will get locus y is equal to minus b square upon a square m times x. This is one way of doing it. The second way of doing it is, if x dash y dash is your midpoint, you can directly write down the equation of chord AB in terms of its midpoint T is equal to S1, and simplify, you should get the locus. So this is what is the answer. Next.
सर
Yes.
सर कॉर्डची इक्वेशन वापरून सॉल्व्ह केलं तर लगेच येतं, कारण आपण आधी त्याचं कॉर्डचा स्लोप फाइंड आउट केलं होतं m इज इक्वल टू मायनस बी स्क्वेअर x1 प्लस x2 होल डिवायडेड बाय a स्क्वेअर टाइम्स y1 प्लस y2. मग x1 प्लस x2 बाय 2 आणि y1 प्लस y2 बाय 2 ने सॉल्व्ह केलं तर मग लगेच येतं.
Yes, that is also a very good idea. You can solve it that way also. Now, two diameters are said to be conjugate. If conjugate with respect to each other. Each bisects chord parallel to the other. If and only if each bisects chords parallel to the other. So now in this diagram, suppose my diameter is a locus of midpoint, which happens to be like this. Suppose this is the diameter of AB. Then if you draw chords parallel to AB, their midpoints, if you join, then that same as color, then that line is parallel to these lines. Do you understand? This blue line is parallel to black lines, and this red diameter is parallel to parallel chords. So in this case, CP and CP dash are conjugate radii, and maybe this Q, CP and CQ are conjugate radii, and PP dash and QQ dash are conjugate diameters. Two diameters are said to be conjugate with respect to each other if and only if. So in case their slopes are M1 and M2, then condition for being conjugate diameters. Easy. If slope of parallel chords is M, slope of diameter is minus B square upon A square M. So M2 is equal to minus B square upon A square M1, which makes it M1 M2 into A square plus B square is equal to 0. If two slopes M1 and M2, if they satisfy this relationship, then they are supposed to be the slopes of conjugate diameters. Okay, next is if CP1 and CP2 are conjugate radii of the given ellipse, then their eccentric angles differ by pi by 2. Okay, theta 1 and theta 2 are eccentric angles of P1 and P2. C is the center of ellipse. So, if this is your first CP1, so this is locus of midpoint of parallel chords, then CP2 is going to be here, and actual angle between them is not going to be pi by 2. Actual angle between them is pi by 2 in special case. If this is your P1 and this is your P2, then yes, their actual angle is also pi by 2 and their eccentric angle is also pi by 2. But if this P1 and P2 are not on x-axis or y-axis, then their eccentric angles are the angles which we are not able to see, and the angle between them is definitely not 90 degrees. So prove that their eccentric angles differ by pi by 2. Okay, let me just explain this in brief. P1 can be written as A cos theta 1 comma B sin theta 1. Similarly, A cos theta 2 comma B sin theta 2. This is P2, and therefore slope of CP1 is B by A tan theta 1. Slope of P2 is B by A tan theta 2, and hence you end up getting tan theta 1 into tan theta 2 is equal to -1, and hence if you apply tan of theta 1 minus theta 2 formula, you get numerator tan theta 1 minus tan theta 2 upon 1 plus tan theta 1 tan theta 2, and this denominator becomes 0, and therefore the angle theta 1 minus theta 2 must be minus pi by 2 or plus pi by 2. Therefore this implies theta 1 minus theta 2 is pi by 2. Okay, property number 2. Property number 2 is 1 of CP1 square plus CP2 square is equal to A square plus B square. Okay, this is very simple. You know what is P1, you know what is C, you know what is P2, just simplify and get the answer. Question number 3. SP1 into S dash P1 is equal to CP2 square is equal to P1G into P1G. आता शोधा G कोण आहे? Who is G? That we had described earlier. G is the normal at P, meets major axis at from P1. If you draw normal, it meets major axis at G and minor axis at small g. Check what all can you prove. S is focus, S dash is another focus, P1 is this point, C is center, P2 is the other conjugate point, P1G into P1 small g. Work hard. Only thing to be proved in this is the first part, because second part is already proved. SP1 into S dash P1 is equal to P1G into P1G. We have already done earlier. Only thing required to prove is SP1 into S dash P1 is equal to CP2 square. Now you know coordinates of all. S is AE, 0. S dash is minus AE, 0. Find out these distances, take the squares if you want, and check whether your LHS is equal to RHS or not, and you will get it. Next property. Area of parallelogram formed. formed by drawing tangents. At the ends of pair of conjugate diameters, equal. Find out what is the area of parallelogram formed by tangents at the ends, extremities of conjugate diameter. If you draw tangent at the extremities of the conjugate diameter. Now, see what is so good about conjugate diameter is that the diameters parallel to CP2, chords parallel to CP2, their midpoints are going to be on CP1, right? And therefore, the tangent also will have the slope exactly equal to CP2, limiting case. So CP2 and the tangent at P1 will be parallel, and CP1 and tangent at P2 will be parallel. So maybe you can consider only this much E, and everywhere it is going to happen like that, and eventually therefore P2E is going to be parallel to P2 dash E dash. Everything is parallel to each other. So that is what is the parallelogram, right? Of course, it is not going to intersect on the curve x-axis. Okay. So you know C. So if it is a parallelogram, then it is good enough. Okay, P happens to be midpoint of maybe EF. You can prove that. P can be midpoint because these three lines are parallel. And therefore, you find out area of this triangle CP2P1, and 8 times that area is going to be your required area. So to find out area of triangle CP1P2, you use half determinant coordinates of C 0, 0, 1, coordinates of P1 A cos theta C 0, 0, 1, A cos theta B sin theta 1, and now you can express P2 in terms of P1 because A of cos pi by 2 minus theta 1, comma B of sin pi by 2 minus theta 1, correct? Those are the coordinates of P2. So cos of pi by 2 minus theta 1 is sin theta 1. So A sin theta 1, B cos theta 1. This is CP1 P2. काही ते कुठे मायनस साइन येणार आहे का?
सर ते cos pi by 2 plus theta 1 पाहिजे.
Cos pi by
कारण त्यांचा डिफरन्स pi by 2 आहे, मग इकडे जाऊन प्लस होईल ते.
theta 2 minus theta 1 is equal to pi by, therefore theta 2 is equal to pi by 2 plus theta 1. Acha, everywhere I have to write plus, and then cos theta pi by 2 plus theta 1 is minus sin theta 1. So here there will be minus sign. Sin pi by 2 plus theta 1 is sin theta 1, is cos theta 1. त्यामुळे इथे नको. And this is going to be 2 times, half times AB. If you simplify this, determinant solve this, and this is 1/8 of total parallelogram. Do you want me to prove it? Why it is 1/8? Everywhere it is midpoint, and therefore area of parallelogram is 4 times A into standard. Standard result. Next. Next result is P and Q are on ellipse. If P and Q are on ellipse, on ellipse means on standard ellipse, and CP is perpendicular to CQ. Actually, physically they are perpendicular. Then 1 upon CP square plus 1 upon CQ square equals. Okay, let us do it by some y is equal to mx method. We have an ellipse, we have center 0, 0, we have one line, this is point P, which suppose equation of CP is y is equal to mx. Then x dash comma mx dash is the point on that line CP. Okay, so we have relation x dash square upon a square plus m square x dash square upon b square is equal to 1, which means x dash square inside bracket 1 upon a square plus m square upon b square is equal to 1. This one relationship we have. Now the perpendicular point to this is going to be CQ. What are the coordinates? Equation of CQ is going to be y is equal to minus 1 upon mx, correct? So point Q, if I want to find out, this is x1 mx1 x dash mx dash. I assume one point here x double dash comma minus x double dash upon m. Okay, and it satisfies the equation again. So x double dash square upon a square plus x double dash square upon m square b square is equal to 1, and therefore x double dash square inside bracket 1 upon a square plus 1 upon m square b square is equal to 1. These are the two relationships that we have, and therefore what is CP? CP is, or CP square is m square x dash square plus x dash square, correct? That is CP square 1 upon plus 1 upon x double dash square plus x double dash square upon m square. Yes, I will try for some time and then give it up if it is going beyond my control.
सर
Yes.
सर मग रोटेशन न केलं तर एक्स डबल डॅश व्हेरिएबल इंट्रोड्यूस करायची गरज.
That is also a very good idea. So if you rotate it through 90 degree, rotation ने केलं तर तो पॉइंट डिस्टन्स सेम राहणार नाहीये ना. हा आता जरा हात घातलाय तर बघूया काय करतोय ते. दिस इज इक्वल टू m square x.
कम्प्लीट पायथागोरस थेरम वापरून करू शकतो ना.
कंप्लीट पायथागोरस थेरम वापरून करू शकतो.
त्याच्याने थोडे इझी होतील कदाचित कॅल्क्युलेशन.
अच्छा. So एक minute. इथे आता x dash square is there with me, so I can do this. X dash square inside bracket m square plus 1. Suppose I put x dash square here as a square b square upon, this is 1 upon a square b square upon b square plus a square m, that is the value of x dash square, into m square plus 1, that is 1 upon cp square. Okay, so if I want to simplify 1 upon cp square, will I be able to do it? Maybe yes, which is equal to b square plus a square m square upon a square b square into m square plus 1. Okay, similarly, this is going to be x dash square common inside bracket 1 plus 1 upon m square. I can simplify this and say m square upon m square plus 1. So next is m square upon, if I substitute x double dash square here, I get a square m square b square upon m square b square plus a square, that is x double dash square into m square plus 1. This is 1 upon cq square, this quantity, which we can write as m square b square plus a square times m square divided by a square b square m square into m square plus 1. Is m square getting? Or is my m square getting cancelled? Is this correct? Yes. A square m square b square is LCM, which goes in the numerator, and m square b square plus a square gets denominator, and therefore m square gets cancelled, right? And hence you end up getting 1 upon this denominator is same now, which is a square b square into m square plus 1, and numerator is a square plus b square plus inside bracket a square plus b square into m square plus m square, correct? And therefore you end up getting a square plus b square upon a square b square. Array, it is coming. Thank God. That is what is this result. Don't take special points, students. When you are preparing, you should not. When you are appearing in the exam, you may. And you are supposed to be very sure that if the result is in general true, then it is true for specific points, and therefore you get it. Surprisingly, I have not made any mistake and I got final result. Okay.